points we were going to cover. A little bit of intro here, and then and I'll hand it over to Nick here to begin the discussion.
Right. So the discussion here is on data assimilation. And before we started, we were going to ask if Eric he was going to show one slide, mainly because he has developed a data assimilation method that's a little bit different, related to sort of forcing estimation. And I think that's relevant for the discussion, and also how this sort of method might fit into a framework like JEDI, since it is sort of different and it's worth considering. Since I think from what we heard in the morning session, the Navy is also doing something similar of like this sort of forcing estimation. So we wanted to discuss that. So if you could please bring up the one slide, and then Eric will go ahead.
It's actually 2 slides, so I'm sorry. And so this is actually a slide that Tom showed yesterday in his overview slides of the DA system. And so this is work that we've done in adapting our DA system, and I'll go into a little bit more what that means in a second, but adapting that to the WAM model. So this is just the thermospheric side of things for right now. And we've run this on several storm cases. This is the 2013 St. Patrick's Day storm. And let's see here. Here we're showing the neutral densities that are going into the system. In the background, you can see the raw densities along the orbit, and there's a lot of variations there. And this is more like an orbit averaged density time series. So you can see this method works pretty well to take away the bias of the model. And I'm not actually showing the free running model, but it's fairly biased, and that's to be expected on pretty much any thermospheric model that is not calibrated in kind of a real time or recent kind of a setting. But here are the RMS errors here, and this is the red curve here is of the WAM free run. So you can see during this storm here, there's a huge peak up to 70-80% RMSE, and the assimilative output is driving that down quite a bit, especially during quiet time. It's handful of percent, and then during the storm, it's maybe up to 15% RMSE, which is not too bad during those times. But again, here this is the mean model to observation ratio, and see you can see the mean bias here of the free run, and both the prior and the posterior are pretty much unbiased. So that's a good thing, and then the standard deviation decreases as well. The prior I'll mention is kind of like a 3-hour forecast based on whatever conditions and geomagnetic conditions and solar conditions that were estimated about 3 hours prior. You run that 3 hours into the future, and you can see the bias is still pretty persistent at this 1.0. So, this is a little bit. This slide is just kind of into our thinking of how we in terms of the Sword Center, how we would integrate this kind of a method with the operational run of WAM or WAM IPE that's happening within the National Weather Service. And so this is kind of the current WAM IPE DA system, and the DA that's going in there is sort of the lower atmospheric component. Data sources up to about 60 kilometers are being assimilated. Then the wiggles and everything you get out of that are propagating upward, but there's no thermospheric DA, nothing above 60 kilometers or so. So and so this is kind of how we were talking about integrating these two techniques in this cycle, and it's very kind of a high level overview of how this might work. Since this was proposed, there's been a second ConOps added to the WAM IPE output, as Sue Wei was talking about yesterday. And so I think there's a much simpler way to integrate this now, maybe branching off of the ConOps 2 way of running the model. So, but essentially, this is really this method is trying to get at the problem that Dan brought up, and actually some of the problems that Fazlul brings up in when you're constructing your ensemble spread. You need to be taking into account the variability in the forcing, and you need to be running the model long enough so that you can see that variability from the forcing. If you're running it, if you're assimilating every hour, your model doesn't have enough time to respond to the forcing globally. It doesn't really capture it's not a valid test of what the variability in the model is from the solar and geophysical geomagnetic forcing. So this tries to get at that, and we're running the model a lot longer with that forcing to get a better spread. We're running it about a day. And so it's a very different technique. And so I just kind of to put this in the back of the minds of some of the JEDI folks, like this is I don't know if this is possible to or feasible to get this to work with JEDI, but it's just done a little bit differently. So yeah, sorry to take up too much time there.
Okay, thanks, Eric. If you could go back to our document, that would be great. So we divided the discussion into, I think, 3 parts, and we have less than an hour, so we would like to get through all of them, and that way, we will at some point try to cut off discussion on certain points. So first, why don't we skip the background error and skip to DA methods and discuss that first, because Eric was just talking about this. So we'll discuss the second bullet here. And we put in a few, comments here. One is doing forcing versus state estimation. There's kind of 2 different groups doing different things. Some doing just forcing estimation, some doing just state estimation. And I think, the NRL group is maybe the first to be doing both. But, if you're doing both, there could be some issues in terms of how you sort of separate where things go. And then, how you really do the parameter estimation, could this be sort of built into a bias correction? Other things related to, DA methods is, I think everyone is essentially doing ensemble methods because it's in some way a bit the easiest to get started in terms of getting covariance information, things like that. But it's maybe not really the best. You'd want to think long term. Can variational or hybrid methods, is that really the way community should be thinking? And of course, then that comes with other issues, and notably the last point here. We don't have model adjoints for, I think, any thermosphere ionosphere model that I'm aware of. So that would need to be developed, and could something be done in a simple way that would be effective enough? So that's where we, the 2 of us, sort of started thinking, and we'd welcome any comments or suggestions or on these points.
So we've been working with Eric on some of this data assimilation method, but we also realize that it's super difficult to have those IAU GSI and then figure out what to do on top. So I think that's a challenge in the future. And how do we do godiness consistent? And we also don't have a V3 WAM ready. So I think there are a lot of gaps that I don't know where to go.
Sorry, I missed that. You don't have the what ready?
I don't have the FV3 WAM ready for JEDI implementation, right? So I think there are a lot of nothing is ready at that point. So I think there's an advantage of forcing for the thermosphere, but ionosphere might be really tricky because there are a lot of localized feature. That's what we're looking for, right? So changing the forcing is not going to change the structure in the ionosphere model that we're looking into. So I think that's a problem. The other thing that we're encountering with the forcing that we're doing is can't just change the force. Then what I'm going to do with the forecast, right? If I change KP and forecast, KP and F10 now, what I'm going to do tomorrow, right? So I think we kind of work out some method with Eric just to change the physics in a model with some index or some tuning factor so that it's not touching the external driver. But how constant those drivers need to go into the forecast and how does that model bias need to be carried out? It's a challenging. If it's okay to separate nowcast and forecast, but once you have a system, need to do both. I think forcing it appear to be quite challenging as well. So just some comments on that.
Yeah, I think some of the things with dealing with this forcing and different methods of forcing and ideas within the Jedi method, it seems to me that there's this possibility of multiple data assimilation cycling that we could possibly take advantage of. Where is that? I mean, one thing that I am thinking of already is that we might, once we start forcing with the Neptune model, that we might have a global data assimilation solve, which would do, take care of biases. And once we solve that global solve, then we would go into a localized data assimilation technique. And as far as how I have seen something like what you just presented, I've never seen it before, but I wonder if there couldn't be like this sort of iterative data assimilation cycling that we could do. But it's certainly like, important for us to consider in the future of Jedi of what things that we need in there for them to make our systems, workable and runnable. But yeah, I will say one thing just for the advancing of the data assimilation algorithms. I think, for right now, I have to say that hybrid variational ensemble is probably the way to go. But that's just because of what has been shown in the troposphere. And so it's and so I sort of have that, like when people ask me like 15, 20 years down the road, yeah, I guess we're going to have to go there. But I haven't started thinking about, doing the adjoints and everything. The only thing that we have been looking at is the possibility of using this ensemble tangent linear models. And so possibly there's a way to go through there. But anyways,
Well, yeah, please. Yeah, and of course, adjoints, there's also some machine learning is a way to maybe get an approximate.
Just this is kind of real top level, but in terms of framework, and I'm not 100% sure for what your mission statement is for Jedi. I get community aspect of it, but so the issue of latent data and how it gets put into kinds of frameworks and whether you want that or not. I mean, if you're just trying to study sort of the physical phenomenology of the model output, you can assume data is coming in real time, but in general, that's not the case. And so at least having a framework that can account for that. And it also does speak to the kinds of things Eric was just saying. And in general, you have, when you look at operational model output, you have a ensemble of outputs. It's not, you have a, T0, you have T minus whatever, you have T plus whatever, and there's this range of outputs. So that has to be, at least there has to be a nomenclature that can handle that. It's pretty easy to implement, but it needs to be implemented. And then the other thing I was wondering about in that context is when we have measurements that are integrations over long periods of time, like we heard with gold, is a half an hour. Well, that's kind of a weird thing in a way, that if you don't somehow create a framework that's able to either decompose that in time or something to get that right representation when you're simulating in the model, you're going to end up with.
I think that's the same issue with like the orbit average neutral density, where you maybe have a 90-minute integration, and how do you deal with that in your model, because it's really like the average over a 90-minute model forecast or something. Like, so it's the same thing, maybe even worse, because 90 minutes versus 30 is in an ionosphere quite big. Yeah.
And we have a question online, Valerie.
Yeah, basically, thank you. So when we talk about the state and source estimate, so of course you need to adjust the forcing, you need the long-term runs, and basically what we can do, for instance, for operational improvement, we need to do regular retrospective estimation of the analysis of a recast performed by operational model. So when you consistently during, say, 2 weeks before current forecast, do estimation of evaluation of model forecast analysis, so you can get information about systematic model errors biases. And after that, you can project on the estimation of KPF 10.7, whatever. So this information we need to combine regularly. Not only just look at the forecast of one AP, but we need basically to have probably 1 month monitoring of model error forecast and analysis. In this way, we can apply what Eric Sutton actually proposed to do this idea estimation of forcing, etc. This is a similar thing what we do in, for instance, a long time ago for chemical data simulation. For instance, if you need estimation of pollution, so you need forcing. But forcing you can estimate only errors on the forcing you can estimate only if you have information about model biases, and after that you make projection of sources of this pollution. Similar here for 10.7 and KP, I guess, but only time scale is a little bit faster. So basically, the conclusion, the monitoring and persistent forecast error of operational model is probably the most important part of for improvement of operational forecast.
And the other thing we have encountered during the big storm in May is our model actually crashed. So I think the stability of the model is critical because what we think will happen is actually our DA system triggered a unrealistic big wind and go all the way up. We're seeing huge wind going up. So I think then we're start considering turn it off when the KP goes really high because it really doesn't matter, lower atmosphere. So I think there are a lot of design consideration for what we're looking for and how robust the model is and combined with the DA system. Because we never got encountered model crashing before we test with the lower atmosphere DA together. So it was bizarre situation, something need to be think about when we moving forward.
Yeah, I think the model crash situation, we've started running into it as well, especially with the thermosphere. And that's something that's, yeah. And that's just running it over and over again, as many conditions as you can and trying to get your handle on how you can deal with it, but it's really a problem. Getting back to what your point was of what's the what's the sort of the grand thing of what is Jedi going after? What Jedi is going after, I think, is operational data assimilation. So this really what you were raising with the time window and when observations come in, that's what we're working on. There is some of Jedi, and correct me if I'm wrong, which, yeah, we want to be able to do retrospective studies, but it's really for the operational centers. That's what we're going towards with this and in operational setups.
Well, I like the point about, having some retrospective where you can put in all the data that wasn't available at the time when you ran. So you can, look at that difference between a real-time run and that run to try to infer some of the systematic mile. I mean, seems like that's a big point, that those are largely unknown. And the window for me, I'm still very confused because I understand the structure changes very, very fast on the order of minutes. But the forcing happens 3 hours prior that's driving that structural change. So And the timescales are different between the thermosphere and ionosphere. So we got that from the Gold talk, which was thermosphere assimilation mostly focused. And he was talking about a 3-hour lag, and then there was a 1-hour lag when we switched to the ionosphere in a later talk. So there's 2 different lag timescales in the 2 different regimes.
Add 1 or 2 comments about, I think what you said, we're targeting operational implementation, but we are targeting also operational implementations in 5 years. So we need to do research. So JEDI is really not just for what's done today in operations, it's for what's going to be done tomorrow and the day after in operations. That's otherwise, we stick with GSI. What's the point if we just want to do exactly the same? And so a lot of the things that I've seen here, like forcing estimation, even observations that accumulations over a period of time. I remember a while back, there were some people trying with rain gauges, rain accumulated over 6 or 12 hours. You can do that. But all these things can be done. I've not seen so far anything that's fundamentally a blocker. There might be a bit of technical work to put these things in, but I don't know, maybe we'll hit something that we can't solve. But so far, at least in principle, I don't see any blocker things you've listed here. You're missing.
Well, and I think, Dave, you're really proposing combining those top 2, that the forcing, because that single F10.7 then gets split into like 7 terms through parameters in the model. So you want to actually have parameter perturbation with your forcing perturbation, but you don't want your model to go unstable, has been brought.
Yeah, and that's actually what Dan was showing in his results, is that it was the combined forcing and state estimation at the same time. So that's why we're going forward is based upon his results for that particular setup. And now maybe that won't work for everybody, and we don't even know if that's going to work that well once we start forcing it with Neptune on the bottom. But it's what we're going first step.
How many ensembles do you need ideally in this? Because you talked about.
I think what we've been, and Dan, I think you're online. I think we were working with 30 or something like that.
Yeah,
Dan
we were
can-
working with 30, that's right. But I mean, I think this is always the same thing. We want as many as we can.
And I'm not wondering about this, but the issue of regional versus global, they put some different constraints on how you do things. I mean, we saw the sun-centric geometry from Eric, and we've, different things there, but and regional and global also brings up the idea of nested grid. Probo community. But again, just listing things that.
And I think, I mean, I don't want to speak for everyone, but I think there's probably interest in nested grids in some. I assume the Navy, I assume Neptune can do nested grid, and in the future with WACOM-X, we want to be able to do, I mean, the dynamical core allows us to do nested grids that we're going towards. So at some point we might explore that, and I would think maybe FE3 I think can do nested grid as well. Yeah.
Confident we can do FV3 WAM with nested grid, because that required changing all the temperature physics. That will probably.
Yeah, there's sort of complications when you go to a nested grid of how you deal with gravity waves and making them scale aware, so you're not double counting and all sorts of things. But anyway.
Yeah, so this is a kind of different topic, but I think it was kind of brought up in the meeting, but just like the forcing dependence of the upper atmosphere, like if it's just less initial conditions, we really need like forecasts of like F10.7 and KP and all that if we want to do like daily, like the next day forecasting, which is kind of, there's probably machine learning approaches that I think we're really thinking about the magnetosphere or other solar physics kind of fields have kind of looked into this, but yeah, that's just like another whole issue if you want to do like daily forecast, because we don't know until like only we know it for nowcasting, I guess, right now.
Yeah, we've been working with some F10.7 modeling, and I'm sure there's some people here that know a whole hell of a lot more than I do about where we're getting into that. I think it's important. I think it's really important, obviously, and hopefully from the community that we can get better, solar forcing forecasts of some sort. I don't.
Yeah, I'll just mention that current NASA program under the Living with a Star program called Beyond F10.7, in which they're hoping to provide inputs into models that are beyond a single index. That said, I'm a member of that team, and our team is doing a machine learning model regressing from the far side helioseismic measurements of solar active regions onto solar irradiance. And as a start, F10.7. So in other words, imagine using a far side image of the sun from helioseismology to infer what the F10.7 is on the far side of the sun. Now you have something you can just rotate around, and you can monitor that every hour if you'd like. So every hour we'll be producing F10.7 on the far side and then having a model of the sun that rotates around. So we should be able to get, I'm estimating, a good 3 to 5 day F10.7 forecast from this method. We hope to have that running within about a year. So and then we'll go beyond F10.7 to have an actual solar EUV irradiance spectral forecast from just looking at the helioseismic far side.
I think we should move on to the other topic. This is good discussion. One point I would like to make on these question of forecasting F10.7, I think it's also important to have a database of what was actually forecast for F10.7 and KP stored somewhere, so that if you want to go back and retrospectively run your model and have a sense of what the true forecast was, you can actually do that. Because I think
part of our program too, because in order to produce an F10.7 forecast, we have to know what the current state of that forecasting system is, and it's abysmal, and the data is very hard to find, but we are collecting all of that. So as part of our project, we should have an F10.7 forecast database for the community to look at as well.
And SWPC does have it. I have all the data back to 2011. So we are sharing with some people.
Okay.
So one of the activity we're doing with AFRL, actually with Space Force, is really using the new AdaptSIFT project to improve our forecast, and hopefully so we're going to include the solar imaging from the ground in real time to improve that KP in real time. Then on that KP F10, then we're going to include the far side imaging into those systems. So I'm just saying there's a improvement going on, and we also want to figure out how bad we're doing in the forecast, and so can improve it. So there is accessible if people are interested.
I mean, good or bad, I think just having access to it so that people can run experiments of, if in 2015 I want to run something and have a realistic solar
And then my
forecast,
goal,
you can do it.
our goal is really also getting us uncertainty of those index, because it's always like 85. What does that mean, right? So I think that moving the future is all this index need to have uncertainty and range of errors on that, so that people can probably include that in your model as a range of error or something.
Atmospheric modeling, getting away from a single number describing.
Yeah,
the sun.
so we also have intention to, the GHOST team has been working on EUV bands, and our goal is in 12 months from now, we're going to release the real-time bands for the model to be utilizing, and the cadence of those bands, EUV bands, will be determined, but it can be really fine, and you can use it for research or operational need. So that we're going to try and move away from that and provide real-time product.
Okay. So we've diverged a little bit from the data assimilation methods, but we'll try to get back and discuss the I didn't say it was not a good discussion. I just said we've diverged from data assimilation. So related to background error, yeah, there are several topics that I think have been discussed during the meeting and we came up with for discussion. Yeah, there's a question of how much can be done, for sharing methods for creating sort of background covariance, and we don't really have static B matrices at the moment for any model that I know of, and can we construct them and
Do we need them?
yeah, that's another question of, are they needed and can they be shared? One thing that I don't think has really been discussed here, but is an issue, since pretty much everyone is doing ensemble methods, that means you need to come up with a good ensemble. And depending on how you do that, some areas of your model are more or less well dispersed versus not. For example, if you just spread F10.7, your night side ionosphere doesn't get much, spread. So that this is actually, I think, a important topic. And then there's the issue of localization, which I think we discussed a bit yesterday, in the context of what frame you're doing it in, if you're doing a geomagnetic frame or a sort of regular lat long, how you do that localization may be better or worse depending on what reference frame you're using. So I don't know if anyone has comments or thoughts on any of these or anything else related to the background errors.
Yeah, the ensemble construction, I mean, that's that's the huge one. And yeah, I think that for the years to come, as long as we're going in the ensemble direction, we're going to be discussing everyone how to build and how to construct to get enough variance in everywhere that you want and everywhere that you need and all of that. And that goes hand in hand with the localization, obviously, as well. And how do we come up with localization methods that don't cut off the spurious stuff, but leave what we actually want and what we need to pull out of it. Yeah, this is just never going to end in conversations.
Yeah, I would agree, but I think it's quite important because it really does matter how effectively you can assimilate data. So we have a comment or question online from Ricardo.
Thanks. I was just gonna say that, I mean, obviously that's probably obvious to most of you, but you're talking about climatological type errors for whole atmosphere models that sort of really go from the surface up to the levels that you are interested in, and I'd say that maybe you can do sort of somewhat the reverse of what we normally do in a WP in most of our hybrid systems, which is we tend to, above a certain level, start relaxing back to the climatological background errors and rely less on the ensembles. You could actually reverse that so that you actually, you have some sort of a hybridization, regular hybridization down to the in the troposphere and the lower stratosphere, and then you relax to the ensemble instead, so that then you can go as high as you want, and you don't necessarily have to have any climatological information, which I'm sure is tough for you to come up with. So that would be something to think about. And then you get hopefully a reliable troposphere and stratosphere.
Yeah, to expand on Ricardo's comments, I think one fundamental question, which I have no idea about, is how much is how much of the background errors are flow dependent at the cycling frequency that you're doing, and how much are actually systematic or climatological. Then there's once you start figuring this out, that helps on the level of hybridization that Ricardo was mentioning earlier. And I'd say on the technical side, if you have an ensemble, you have a static B. It might be very poor, but you can take your ensemble members from the last 5 years. That gives you a static B. And I think actually Ricardo has tried that in the past. But and then you can refine technical refinement or complexity of your static B. But I think the fundamental question is how much is actually persistent climatological, how much is evolving from cycle to cycle, and that's something I have no idea about.
And there's a question online from Valerie.
Yeah, basically, the comment is for the ground error. We need actually to build something like climatology error for hour, because above roughly 100 kilometers, the diurnal and semi-diurnal tide become dominant motions for all dynamics. And so we have experience building with for GSM WAM errors of an hour, and if you look at the plots, so it's significantly dependent. You can see the terminator behavior, and of course it's flow dependent. So it would be good for whole atmosphere modeling to get something like for different seasons, perhaps the climatology of with static background terrace of our, but we definitely need not to go to something like climatology, zonal mean or whatever. We need definitely to get three-dimensional every hour specification of variances of all state variables, which is we would like to constrain by the data. This is probably possible way to proceed and basically to somehow to unify representation of background terrace. So I called diurnal variation of static background terrace. So we need it definitely. Thank you.
Yeah, and I would add it probably also varies by season and presumably solar activity.
That's correct. Correct, absolutely.
So I just want to mention that, and I'm new to this, so perhaps this is an already, thought of and perhaps discarded method, but there are plenty of numerical methods for creating covariance matrices given, significant quantities of data on these states. Is that a approach that has already been, thought of and discarded, or is this something that we could perhaps use to maybe create at least some initial static B matrices and for all these different variations on these states? I just want to know if this is something that's already been worked through.
Yeah, from my understanding is that it hasn't been, I mean, people have been looking at it, especially in the observations to see what correlations are there. And we've started, looking at the models, but no, it's a great point is that there's a lot of methods out there that to create these error covariances. And yeah, I don't know, Dan Hodis, do you want to say anything on it as far as methods to look more into this? Sorry to put you on the spot.
You mean generate methods using, there's Hauswirth and Loneberg and Desrosiers. I guess that's what you're
Right.
referring to?
Yeah,
Yeah,
I mean, that's one. Yeah, go ahead.
Yeah. That certainly is, if that's what was being discussed previously, then yeah, we should really be doing that here in the ionosphere as well. But we need to get a data assimilation system. All those methods rely on having a data assimilation system running for a long period of time. So we need to get one set up and ready to go, and then collect innovations, analyses, and forecasts, and apply those methods to estimate both the background and the observation errors.
I agree, Dan. It seems like, yeah, the static B seems like something that is not a near-term thing. Ensemble is going to be it. I want to go back to the first point before we jump off to our final validation topic. But on the convergence of state variables, we have the PyRI SAMI, we have WACMX, and we have the WAM IPE. Do they do the thermospheric ionospheric models? Is there a convergence of the state variables? Do you use the same ones? Because this is very critical to JEDI. We do have a variable transform Vader component where we can try to but we want all these to look homogeneous. That's really how the UFO is agnostic to the model. So I saw someone was smiling, so I'm guessing no, we don't have a convergence, but this is a key point, and I think this is one we probably could make some traction on in the next year or two. And it would really facilitate getting all these different model interfaces established. Francois H, do you want to say anything on that? Or, I mean, did I say that okay? Oh, I agree.
I think, I mean, maybe I'm wrong. I think for ionosphere only models, they should have the same state variable, which is electron density, because that's it. For coupled models, I think they would have the same primary state variables, which would be, you know, neutral composition, temperature, and neutral wind, and an ionosphere. I can't think of any model that would be doing something different, but I might be wrong. Yeah, I guess there's, yeah, but they could be converted to the right, you know, format. There is a question of if you're doing, and then, I mean, there's different mixing ratio, mass versus volume, but they could be converted to the same thing. You know, some agreement on what that should be would be necessary, yeah. And someone correct me if I'm thinking of a model that is doing something different.
I guess I would say that the SAMI 3 model is different. I mean, you said the ionospheric models only have electron density, but SAMI 3 model is a Navier-Stokes model, which is, it has all the variables, and you need to update all the variables within it. At least that's the
Right.
approach that we've taken.
Yeah, I mean, there are ion species.
And ion winds and electrostatic
Yeah.
potential.
Yeah, but we don't have much data to drive data simulation for any of that.
Well, but there's
We only have-
we don't need them. We have covariances, right? I was updating everything at once.
Right.
So you do want to have, I mean, are you saying, maybe I'm misunderstanding what you're saying. When the B is a background for the entire model, if that's what we mean, or maybe we're talking here about HBHT. If we're talking about HBHT, then yeah, then there's only electron density. But if we're talking about B, there's a whole lot more.
Well, yeah, we would want, yeah, we have the same problem with clouds right now. Yeah, if you have a B without the cloud, you can't update the cloud. So if we want to update them all like it sounds like you do, we will need them all. But yeah, Sue.
So how we doing the WAM IP right now, I think it's probably very similar to what you have to do with SEMI 3, is you have WAM, and then with ESMF, we put it into fixed grid and we do interpolation, extrapolation. So I think they're a middle ground with how we want to do the job in between. But yeah, I mean, those parameters is exactly what we do, right? Wind, composition, temperature, and that's why you have MSIS and HWM in those systems. It's the same thing.
Yeah, and what we took for the standpoint of the different ion species, because pi IRI really only has ion density, what we did is we faked it, and we said that it's actually, we just split it into two, so that it was one ion and then another ion, and then it's sort of like then you can have whatever number of ions you have in your model, you can expand that vector out. And so that what's running online right now, it has two ion species that that can be expanded to more, but that's how we did it.
Yeah, I mean, most models have multiple ion species, but I mean, O plus essentially dominate in the F region. So, and I guess you can rely on your model to separate them, but yeah, you're basically just doing whatever the model internally wants to do. There's no observation information to guide that.
Exactly. No, that's for sure. It's not coming. We're not right now. We don't have observations that would allow us to tease out that and yeah, bring that up.
We should probably move on to the valid. Can you scroll down to the validation part? It's the third bullet there. And this, oh, I have to hold this. This probably is one of the trickiest ones, which has come up a lot. I think the databases we've talked about are going to be critical here. This one that just came out about the F-10-7. I don't know about the solar wind KP and IANA, some database of F1, F2 or something. But why don't you take it away, Nick?
I mean, I put on the spot for the hardest one. I mean, really, I think this is my perspective. You know, validation is not well done. For the most part, it's sort of a bit ad hoc. Everyone doing their own thing. Almost impossible to cross compare. You know, what if I make some change to my model and want to compare with whatever NRL has been doing or Swipsy has been doing, good luck. So having some easier way to sort of cross compare, we don't have sort of reference reanalysis or reference observation defined that you can do that against. So I think, we need to have some reference that people can use, and ideally a sort of software tool that can do that. And some way, ideally independent, but that gets harder. And then there's a question of could a standard reanalysis be used as a reference? I think the issue there is we don't really have one that exists, or one that could be developed quickly as a sort of confident reference as truth. So that's my comments on this. I don't know, Tom, looks like you have a question, and then Victoria.
It's not, well, it is, it's, and pardon my potential ignorance on this, it's more of a question of terminology. And when you say validation here, are you talking about model validation? In other words, sort of retrospectively looking at, is the model performing as it should? And is that different than forecast verification in the potential tropospheric weather world, for instance? You talk about forecast verification versus model validation. And is that what we're talking about here, or?
Well, for DA, I would say analysis, but yeah, forecast and analysis verification are going to be hand in hand. But for DA, I would say analysis verification, which could be a forecast. Yeah, that's going to be the same tool. But the other part that ties in is the observation, that using the observations to forecast, and ideally use one that you didn't assimilate, and then did your fit get better to this observation that you didn't assimilate? And that's an indicator that you've done something correct.
And that's what you're calling validation here, or?
That is a.
You can hear that my confusion is between these terms, validation and verification, that I hear thrown around. Is there a difference, or should we care? That's my question.
Say something. Yeah. I mean, I use them basically interchangeably, but I mean, I guess we could split hairs or whatever, but I think, I mean, we're trying to prove whether or not, one, the models are acting correctly when we're doing our forecast. We're trying to prove that our data assimilation is getting better by looking at your analysis. And I think, how can we do that, as a community? So that, as you say, that we can compare against everything. So what we have started doing, or what the direction that we're going in, I've mentioned it a little bit beforehand, is that we're getting our observations into IOTA, and we're getting our observation operators into JEDI, so that we can take our state spaces and get them into the observation space. And then we can compare any observation to our state space. And that could be a forecast, or that could be an analysis. And then that output we are putting into the MET Plus software system, which does the statistical analysis and making the plots. So anyway, that's where we're sort of going. I think definitely up to the IOTA would be a great direction. So that as soon as you get your model into JEDI, then you can start using the observation operators, and then we can start comparing against. But anyway, that's what we're doing.
That was very helpful. Thank you.
During the summer, we have completed a study of the validation study against incoherent scatter radar data. And we're currently publicly releasing this code. So I can put it on GitHub and kind of advertise in the community. So there are 4 cases, 2 solar minimum, 1 kind of like medium moderate condition, and 1 solar maximum, when at least 2 radars had data in the same time. And we can provide kind of this parameterized incoherent scatter radar measurements. Like the duration is like 5 days. Each event is 5-day long, and you will have the truth at one location in terms of NMF2, HMF2, thickness of top side, thickness of the bottom side. And we have a code that does kind of like a nice root mean square error analysis. So if you just provide the output from your assimilation in a regular grid, it will do this trick for you.
Wanted to make an additional comment about reanalysis. I think you shouldn't be stopped by the fact you don't have a reanalysis. Using ERA5 as ground truth only works if you're not working at ECMWF. And because the operational system at ECMWF is better than ERA5, so you can't use that to verify. And that doesn't stop ECMWF from making progress. So I think there are, different ways you can validate your forecast and estimate how good it is, but the fact you don't have a reanalysis shouldn't stop you. That's, again, if you want your system to become better than your reanalysis, that's not going to work for you. So the reanalysis is very useful for many things, but it's not the answer to everything. And you shouldn't be, too worried about not having your reanalysis get started.
Yeah, tend to agree with Yannick there, because if the ultimate goal needs a reanalysis, we're not at the point yet where we can do one. But we do have, it seems in this community, quite a few different models that can be used and a lot of different observations that can be assimilated. And it feels like there's a lot of room there to actually do some very good validation or evaluation of how the system performs if we get JEDI developed to the right level to facilitate all of those groups. And there seems to be a whole lot of space there where we could learn a lot, and that will guide us to the reanalyses that we need down the road.
Ricardo online has a comment.
I just have a somewhat straightforward comment. I tend to think, about the validation versus verification. I tend to think of validation as something that's done against data that's not assimilated. Once the data is assimilated, then I believe that what's being done is just a verification. So it might help a little bit sort of separate the two. I mean, obviously that's just a matter of choice, but that's how I tend to think.
Thank you, Ricardo.
Yeah, I know different communities do it differently. I'm not going to split that hair here. Sorry, there we go. But to go back to some of the other points, so when I'm doing validation, I'm normally doing validation on something that's not a state variable in my model. It's a different approach, and there's reasons why that's useful to me. But, for example, if you're trying to generate maximum usable frequency between 2 locations, that's an objective variable that can be used to assess the utility of a model for a particular application. And then, that's something we do. And then on top of that, we would try to kind of curate a data set in a particular example. And we've seen that already. This community likes to use the the October storm has been doing that for decades, and it's a great example. I don't know myself how well you all sort of curate and cross-correlate what you mean by that and what data particularly is being used. But if you're really trying to do a one-to-one comparison, you, even in time or between models, how well you improved, you would like to know specifically that you have a well-curated data set that you're putting in, what its limitations are. Everyone understands what it is, so you kind of can get ready to do it. And then you can easily go through the steps. And, Victoria gave an example of something that she's done with ISR, which could be an example of a particular curated data set and analysis set of tools. And you could have a collection of those. And so often when we're updating a model, we have, a few different things that we've collected over the years, and we've curated it. We kind of know, we've even done some manual, interventions in places where things weren't good. And then when we do an upgrade to the model, you put it in there and you redo it. We've done that, maybe 20 times as a model grows over a period of 2 or 3 years. So, and we have found that useful. And in terms of validation and verification, once you start doing that and you have that many examples, some of these things do drop out. Like, are we using leave out data or not? Or are we trying to just say, did my subroutine that I put in there screw up the code in a way that I'm now generating in the high latitude some artifact? And that's more of a verification to me. And then a validation would be, did that subroutine actually improve my ability to generate a muff or something else that I'm interested in?
And I think we've got to wrap up, but one thing you're bringing up that we have kind of glossed over, but it's been brought up, is the validation, or and I'm going to stay with validation, is very customer driven. So each of the different models has often very different things that they're interested in. Some are just the bottom side, some are, you said, maximum usable frequency. So, and there's satellite drag, which is a thermosphere thing. So I think we're just at the point where, and it may already be known between the groups here, but if we can start to get a list of here's the main primary things that you're interested in, and we can collect those. So if we need to develop some tools in JEDI to help you, that we have that superset of metrics that all the different partners are interested in.
I think that concludes this part of the discussion, and then we have a summary session. I don't know, do you want to go straight to that, or were you going to take a 5-minute break? I think it depends if you guys are ready to go or not.
So first I want to ask is, because we are not going to go review the observation session since we just have it. So I would like to ask two chairs, what do you think coming out of this discussion? What are the action items we should follow up? I have some notes I can look at as well, but I would like to, I think what's the best for having a working group is to have action items. And then we can check box in, this is what we discussed, and this is how we follow up on those. And once we do that, we would really proceed with something rather than just putting onto the paper. So, for example, you mentioned about survey stuff. So
yeah, I've got a couple. So going back to the first, I think we need to pursue the forcing estimation plus parameter estimation, which is kind of already underway. So I think we definitely continue that, share. So Dave's already doing this. Eric Sutton's already doing this. It sounds like he's collaborating with Sue Wei, who had to leave for a meeting. So continuing to pursue that and exchange, because it sounds like one of the big problems with that too is you can easily make your model unstable. So how to best do that in a way that gives you a nice spread while not destroying your system. Then the adjoints parts. So there's the ensemble tangent linears that Dave brought up. So those I think are something in the near term that he could try, or near-ish term. But I would like to really poll to see if anyone has some grad students or someone that can explore some machine learning estimations for adjoints as well. It would be, because I think that Because it sounds like the move towards variational is still desired, whether we can do it in 5 years, if we can just get something in the shorter term to see how feasible it is. And then we can get a bit clearer idea of that timeline. The regular retrospective, so this isn't really a re-anal, but if you do a delayed run more routinely, I really like the idea of trying to diagnose some systematic model bias that Valerie brought up. So, you know, that's something that if it can be worked into the plans, it seems like that would be a nice thing to start to get from these systems, to see something with a short cutoff and then something run, you know, later. So that was all under the DA methods. Under background error, yeah, the static B, no. But for me, it was really I think it's been stated that there's largely a convergence, but I would like to have it on paper. Here's the variables that on the ionospheric models, here's the variables for the thermospheric models, and really bring that up. And where do we need to do because we have a component Vader, which is the variable transforms. So where do we need to make some toolkits so we can do a variable transform to make all these models look homogeneous? And then there was the idea of data sets, so curated data sets for an event. And this also came up. There is a F10.7 database that Sue has at NOAA. That would be great to share with the group so everyone knows about. There's the Beyond F10. So that 10.7 and something with uncertainty would be nice. Yeah, well, why don't you go, Nick? But those were some of the high points I had so far.
Yeah, I would agree. I think the one other thing I'd add is the, ensemble construction and how to do that, sharing approaches or, what does or does not work that people have tried, which I think often, what doesn't work doesn't get always distributed. But since it seems like at least in the near, 5 years, ensemble approach is probably what everyone is using. Having a good understanding of how to do that would be, I think beneficial for everyone.
Yeah, it's on your list here, but I didn't really hear it in your summary, but I would add localization on a geomagnetic grid as one of the action items. And also in terms of estimating an adjoint with machine learning methods, I would worry a little bit that we have one G5 storm in the last 20 years. And if you're training your model on sort of more less extreme conditions, would it really apply under extreme conditions? So that's a problem we always have with space weather, is that the events that we really care about don't happen that often.
But you'd have the same problem with an ensemble tangent linear.
Yeah, true.
Yeah, you'd have to probably fake it. Oh.
Those extreme events, like I think NOAA really cares about that. For us at the Navy, we need the day-to-day stuff is more important for us. So, if it goes out, but that's just, that gets into different places, different needs. Yeah.
Oh, and that brings up the convergence on what each of the customers care about. Yeah, so we need to collect that. That's very critical because there is definitely distinctions between the different groups here. And can we wrap away? Do you want to come up?
I think out of my notes, there's one you already mentioned earlier. It's the metrics for the validation over verification you want to have. At least some summary of what kind of variables you would like to have. That's the only item.
Yeah, that's this collection of the customer that wants, because they don't want just a model grid. They typically want something, some index or some. Yeah.
And another action item is similar to any others. We will talk about that is the working group. But I'll talk about that a little bit. So we can let's have 5 minutes break and then coming back because I would like to have a summary for the other 2 sessions as well.
Thank you, everybody.
After 5 minutes, don't run away.
Russell, you got a second, Jeff?